center. That's what Faraday said. But why did he say such statement? Or why did he make such statement is what we are going to discuss now. Alright, in my previous video we discussed, or rather we learned the force exacting on two or more point charges. We learned that. But at the same time, we should understand that these charges don't even touch themselves. They are some distance apart from each other, right? So how is it that a point charge such as Q is affecting another point charge such as Q2, I mean Q1 and Q2 by this distance? Why? And that is what Faraday was trying to propose an answer to it. He was actually trying to propose an answer to this question. How can this Q1 affect Q2 within such distance? All right? So the problem here is for us to understand these concepts and apply it. What happens is that every charge, okay, exhibits some amount of electric field. And this electric field extends what? Outwardly from that point. So when it extends outwardly, it spreads through the space with the charge as the center. So that's what it means. That's what it means. Just take this as the electric field extending outwardly from this particular charge. Take it to be that. Now what happens if this, you can see, extending outwardly definitely is going to affect, is going to influence point charge Q2. Because it's not stagnant, it's spreading through the space. And that is why it will influence Q2. That's what happens. So Faraday and I came up with the fact that the electric field extends outwardly from every charge and spread out through the space with the charge as center. That's what happens here. We can now do a definition of what electric field is all about. Electric field is that region or that space where an electric force is experienced by a charged body. Alright? That's what happens there. Is a region or a space where an electric force is experienced by a charged body. Once this charged body experiences this electric force within this region, that region is filled with electric field. That is it. That's what happens. Alright, so with that, for us to know that there is some amount of electric field within this region or within this space, we put what we call test charge, positive test charge. So when we put positive test charge in this region, you will see the positive test charge being drifted somehow, tracing a line like this, a curve. Tracing a curve. I repeat, how do we not know that there is some amount of electric field within this region? By using a test charge. By the time we place it, the test charge, because of the force it's possessing, begin to trace some amount of curve. This curve is known as electric field line or electric line of force. That's what it means. Now we're going to look at what happens at this point. What happens at points X, Y, Z, K, B, and C down to the last point. So if we now take P and Q to be a path traced out by a positive test charge, okay? It then means we must understand this. These points X, Y, Z, K, B, and C represents the direction the point charge would go if placed at this point. It will go this way. If placed at this point, it will take this. If you place at this, it will take like this until we experiment each and every one of the points. So these points are tangential to the curve, and they represent the direction a positive test charge would go if placed in such points or at such points. That's what they represent. So we now define what electric line of force is all about. Electric lines of force are just imaginary lines drawn in such a way that the direction at any point, okay, this should be at any point, all right, is the same as the direction of the electric field at that point. That's what it means. Okay? I repeat, electric lines of force are imaginary lines of force drawn in such a way that the direction of any point, okay, that the direction at any point is the same as the direction of field at that point. That is what electric line of force is all about. That's it. Okay, if we have understood that, I repeat, if we haven't understood all that, I think it is time for us to consider subscribing, right? Giving me some thumbs up, putting on the bell button for constant notification, and then remember to share with your friends, students, and networks. Belong to this family, right? My returning subscribers, come on, thank you so much. My new subscribers, I respect you so much. Belong to this family. All right, having said that, let's look at this. Electric potential. What's the meaning of electric potential? The strength. The strength, the electric force or field it has per unit area. Let's look at it, or per unit or per point. Let's look at it. The strength of an electric field E at any point can be seen. If this is the point we are talking about, the strength the electric field has at this point is referred to as its electric potential. So this, the strength of an electric field E at any point, and also is the force per unit positive charge. So if we must understand this, we must take into consideration that the strength of an electric field at any point represents its force per unit positive charge. We must take note. And if that is taken care of, we know that E, which is the electric potential, electric intensity, E is equal to force over small amount of charge. And then if we make F from here, the subject, we have QE. That's it. Now, what do we mean by this? We have a line P and Q. P and Q represent some amount of distance, right? At the end, there is a charge. In between, there is a positive charge, right? Let's see what happens. Separated by this. Now we want to find the field strength. We want to find the electric field strength at this point. So what do? We now recall that we have the field strength is E equals to F over Q. But first of all, we need to define what F is all about. And F is given as this, times Q times this, all over the distance separating them, squared. That's all. We come to this point, we recall that our E is given as F over Q. So wherever we see F, we first of all state this, and then attach Q. That will give us all this, okay? Because by the time we take care of this and this, we are left with Q over R squared. That's why I see this factor represents the value of K. K is a proportionality constant, which we discussed or which we learned in our previous video, right? Okay, so that is it. Well explained. But if you think there are steps not clear in my explanation, put it in the comment section. I will explain. If you think there is any point that you don't understand, feel free, comment. In fact, I want to see your comments in the comment box, all right? While you do that, thank you so much. Thumbs up. subscribe, bell button on,